Hi everyone. In this video, I am going to explain about backtracking. This backtracking is another algorithm design technique which is used to improve the efficiency of the exhaustive search. Okay, this is the first thing. The second thing, whenever we want to get the optimal solution for the given problem, we have two choices. Already we discussed that. So that is, one is greedy technique, another one is dynamic programming. So with these two we are using whenever we want to get the optimal solution. So when these two techniques fails to solve the problem or to fail to give the optimal solution, then we have the third option is backtracking. So that means this backtracking is the another algorithm design technique used to get the optimal solution. See, the beauty of this backtracking is this can be applied to both optimization and as well as non-optimization problems. Optimization and non-optimization. Okay, that means this backtracking can be applied to both optimization problems and as well as non-optimization problems. Okay, so generally this backtracking can be applied to the problems which is having large state space. That means which is having some combinatorial problems. That means there are many combinations are there for the solution. For that type of problems, we can apply this backtracking technique. Generally, this backtracking technique can be applied to the combinatorial problems which cannot be solved in the polynomial type. See, generally, the problems like N-Queen's problem, subset sum problem, Hamiltonian circuit, job scheduling problem, job assignment problems, graph coloring problems. So these are the some of the problems that can easily solve by applying this backtracking. So this backtracking can solve what type of problems? So the problem is having many options. Okay, many possibilities are there. This backtracking check these possibilities in a systematic order and obtain the optimal solution. The principal idea behind this backtracking is, see, it can be solved the problems that have multiple options. So now to check, okay, this is the initial solution, nothing is there. So now first you check the first option. So that means first it will come to the first option will come. So next, in the first option, again assume it is having three options. Now assume again we'll check the first option. Suppose if the first option further gives the hopes to get the solution, it will continue. Otherwise what? It will stop there itself. It will mark this as a dead end and goes back. And check the next option. Suppose this option promises to give the solution, it go further. Otherwise, so we'll call this a dead end node. We'll come to the previous and I'll check the next option. Now in the next option, assume this is the next option. Assume this is a dead end. It is not promising us to give the solution. It goes back. Check the next option. Now assume the next option promises. Now again I'll go back here. Now this is the first option. Again to check. So like this, whenever an option or a choice promises to give the further solution, leads towards the solution, it continue. Whenever it says, so from this point of position, it is not possible to get the solution, that means it violates the problem constraints, then it goes back one step, that means it goes back and track from the next option. So that's why it goes back and track from the next option. Hence the name called backtracking. Hope you people understood. So what do you mean by backtracking? For what type of problems this backtracking is applied? What is the principal idea behind the backtracking? Thank you. Thanks for watching. If you have any questions about this, please write in the comments. Thank you.